Good afternoon and good morning to those of you out west. Welcome to today's webinar from Metal Architecture Magazine and Steelscape. My name is Stacy Ranella. I'm the editor-in-chief for Metal Architecture, and I'll be moderating today's presentation. Just to cover a few housekeeping items before we get started, if you have any questions during today's webinar, please enter them using the Q&A section, which you can find at the bottom of your Zoom window. We will address as many questions as possible during and at the end of the presentation. Zoom does have a raise hand function, but since we'll be keeping everyone's mics muted, only use the Q&A instead. If you're experiencing any technical difficulties during the webinar, you can enter a message in the chat, which you'll find right next to the Q&A, and we'll do our best to help. Today's webinar is being recorded and will be available on Metal Architecture's website by this time next week. Now, I'd like to introduce our speaker, Michelle Vondran. Michelle is the technical manager at BlueScope Coated Products North America. Michelle graduated from California Polytechnic State University with a degree in chemistry. She started her career as a research chemist with Morton Coil Coatings with a focus on polymers. This position also included lab development, as well as lab to production scale-up and manufacturing quality and process control. Eventually, Michelle's focus shifted to cool pigmentation, where she brought the first cool coil coatings to market. She was active in the Cool Roof Rating Council and Energy Star roofing program. She joined Steelscape as a quality engineer for the Rancho Cucamonga paint line. As technical manager, she oversees quality systems and technical service for BlueScope Coated Products North America, which is comprised of Steelscape and ASC profiles. In this webinar, Michelle will discuss pre-painted metal. Michelle, we appreciate you joining us today. Please take it away.
Hey, thank you for that. Welcome, everyone. I hope I didn't scare anyone away with the word chemistry or chemist. I promise you we're not going to do any chemistry today. There won't be a quiz on that, so never fear. So yeah, we're going to talk about pre-painted metal, what it's comprised of, how it's made, and then how it gets used out in the construction world, the architectural world. And we will take questions at the end of each section because it's a lot of content. So we'll have some quick breaks. Here's the presentation overview information. It's one credit. Here are the 4 sections. So again, pre-painted metal fundamentals, the application process, how we do it. We'll talk about paint systems in detail a bit, their differences and appropriate applications. We got a section about enhancement options, both design aesthetic enhancements, but also performance enhancements that are available. And then we'll wrap it up kind of with durability, warranty, how to maintain these coatings and metal out in the field. So what is pre-painted metal? I mean, it's pretty self-explanatory. So pre-painted metal is rolls of steel or aluminum, usually, that has paint applied in a factory setting and is baked on. And this occurs prior to any final panels, pieces, parts, and shapes being made out of that roll of steel or aluminum. So not all pre-painted metal is the same. Selecting the right substrate and the right coating, which is what we're going to focus on today, affects product lifespan, energy efficiency, visual appeal, etc. Some of the more common construction products that use pre-painted metal, obviously exterior building products, metal roofing, siding, walls, but also gutters and downspouts, accessories that get used in buildings, insulated metal panels, composite panels, trim and flashing. Those are the ones we're going to try to focus on today. But we also use this product in HVAC products, appliances. Almost all of your appliances are pre-painted metal done by the coil coating process, cabinetry, hot water heaters, door trims, window trims, a lot of other interior stuff. Metal furniture is almost all made out of pre-painted metal through the coil process. So how is the paint applied? So we got a question here. How is the paint applied to metal for the majority of building applications? Is it an airbrush system? Is it dipped? Is it rolled? Or is it brushed on? It's rolled on, but certainly not like we think about rolling paint on, say, in our house when we're painting the interior of our house. So what we have here is a picture of a pretty traditional coil line. The strip is moving. The rolls on the bottom that are coated with paint are also moving and engaged to touch the moving strip. And that's how the paint is applied, done at very high speed, very quick process. This is a schematic of kind of a generic paint line, or a coil line, as we refer to them as. They're all a little bit different in size and how they're laid out, but they all do the same thing at the end of the day. It is a continuous process. So we connect one coil end to end to another and keep running as much as possible. But the coil starts out, enters the line, goes through a cleaning section, get it nice and prepped for receiving paint. We do use a pre-treatment that goes on to create a good bond with the paint. We put a primer on that gets baked on at high temp. After that, then the finish coat gets applied again at high temp very quickly. Speeds are anywhere from 100 up to 700 feet per minute, depending on which specific line we're talking about. So it can be very, very fast. The curing process, that is from the time the paint is applied to the strip until it is dried and fully cured, is 15 to 30 seconds. So these are chemical reactions that are taking place. They are not air dried like house paints that we use. If you sat some of this paint out, if you rolled it on a piece of metal and set it out in the sunlight, years from now, it would still be wet. It would never actually dry. So very different chemistry. There's a lot of advantages that come with this process, mostly because of the size and the speed in which we do things and the way it's controlled. So it's a very repeatable process. All the processes are very tightly controlled, so we get very good repeatability of the coating and the performance. It's a very efficient use of paint. So total paint on the top side and the bottom side of the strip is only about 1.4 mils, so 0.0014 inches. That's thinner than paper. We can measure that small and we can reproduce to that. By comparison, most other industrial coatings or metal coatings are 2 to 5 mils in thickness, so a lot more paint that goes on. Another comparison would be cars, right? So cars are kind of in that 3 to 5 mil range of thickness. So a lot more paint is applied. All of this is done before fabrication. So these paint systems, these coatings have to be hard, but also durable and flexible to go through the forming process and get made into whatever final panel or piece or part they need to be. It is a closed loop system. So these are solvent-based paints. We're going to talk about that a bit more in detail later, but those solvents are driven off in the ovens and are captured and incinerated and or used to reheat the oven. So it is a closed loop system. The final product is VOC free. With great speed and size comes some limitations. You know, it's very rapid, it's very large. That makes it difficult to do very small quantities. These lines are anywhere from, say, 1,500 to 3,000 linear feet of product from end to end. So it's very hard to just paint, say, a couple hundred feet. So it's an economy of scale situation. This can limit the color palette, although we have, I can tell you that Steelscape currently has about, I don't know, 32,000 different colors on file. So not a huge limitation, but, you know, custom colors, exotic colors, small runs are going to cost a lot more and have a lot longer lead time and may actually not be feasible for all coil coaters to do. Pause here real quick. So again, we talk about how fast it is. You can look up videos online if you're curious. The National Coil Coating Association's got some really good videos on what this looks like and the size of it and how quickly it operates. Again, a single car today to coat all of its parts is anywhere from 30 minutes to 2 hours, depending on which kind of car and which assembly line it's on. I can run an entire coil of steel enough to produce 4, 5, 6 very large buildings or more in about 15 minutes. So we get a lot of product very, very quickly off the line. Whoops. Oh my God. Sorry, I went too far. So quality control. Again, we talk about the advantages, really tightly controlled. Both the performance and the aesthetic look of it. So we try to simulate the forming it's going to go through downstream to our customers. So we bend it, we bump it, We stress it. We try to make sure that that paint's not failing, that substrate's not failing. We do a lot of color validation and gloss. That's the aesthetic side, right? That color's got to be consistent, not only within a coil, but coil to coil, from edge to edge, from order to order. If I paint, you know, red number 5 today, when I paint it again next week, it needs to look exactly the same, right? There can't be any visual differences to it. Film thickness is critical. Very, very thin film, tightly controlled, but critical to long-term performance and warranty that goes out in the field. I mean, we're asking this product to go on the exterior of a building that may or may not get routine maintenance, is always going to be exposed to the elements 24/7, and is expected to last 40 or 50 years. So we got to make sure that all of these specs are hit on every coil. I do want to spend a few minutes before we jump into paint, which is the bulk of this presentation, to talk about the substrate underneath, because it's quite important. So coil coating, like I said, is mostly coated steel or aluminum. I'm going to focus on steel here. It's either galvanized, which is a zinc coating, metallic coated steel, or an aluminum zinc coating, which would be galvalume or zincalume. Those are trade names you'll see out there that are specified and written into specs. It's a 55% aluminum zinc metallic coating that has superior corrosion resistance compared to galvanized. There's a whole nother AIA presentation on that if anyone's interested, that I do. But you will see these trademark names in the specs from time to time. We do this in a similar fashion as painting. It is a continuous line. Moves very, very fast. They're actually much larger than the paint lines and move much faster, like 300 to 500 feet per minute or more. We're annealing the steel prior to metallic coating to get the properties that we need of the steel, and what its yield is going to be, how elastic it is, how it's going to form. And then we're also applying this metallic coating on that same line. Different coating weights available, affects warranty and how you're going to use it. Most galvalume or aluminum zinc metallic coating at this point is, I actually need to update this, 20-25 years. It's actually going to move up to like 40-50 years just in the recent months on this product. So I need to update that. But where you install this product is going to affect that warranty. And again, at the end of the presentation, we'll talk about that a bit more. This is a picture here of metallic coating getting applied to the strip before it's solidified. You get that very mirror-like finish. Once it's settled and crystallized, it's a little bit of a duller shine. Okay, paint. What is paint? We all know what paint is, right? I mean, we've all dealt with it. It's a liquid. You apply it to a surface. It needs to cure and dry into a solid film. We want it to protect the surface, and we want it to look a certain way, right? We want to design with it. We want to create with it. So it needs to have the right color and the right look and the right gloss. Maybe it's sparkly. Maybe it's a matte finish, whatever the designer wants. There are 4 primary components of paint. Resins, also called the polymer, because we couldn't settle on just one name. This is the binder of the paint. This is the backbone of the paint. It is going to determine most of the physical and chemical properties of that coating. Pigment, that's going to be the color. The fun part, makes it look a certain way. Our coatings are solvent-based, right? We got to make them liquid. We use petroleum solvents mostly for this. We got to dissolve those solids. We have to have it in a liquid state that's easy to handle, to move from drum onto the coater head. Easy to mix. And then there's additives. These are small quantity things that are added to fine-tune performance characteristics of the final film. So it's kind of how they break down and what they bring to the table, right? These are the players. So your resin is going to be mostly your physical properties: durability, hardness, flexibility, adhesion, gloss, chemical resistance, corrosion resistance, all that good stuff. Has to be able to withstand the elements. Your pigment's going to be mostly color. You need it to hide whatever it is you're putting it on, in this case, coated steel. You can improve corrosion with your pigment selection as well. Does contribute to film strength and water resistance. And then again, the solvent is really for those of us on the application side who are making this product It's about the viscosity, pumping it from drum into coater head, how it flows out on the strip, right? We need it to flow evenly and consistently onto the strip so that that film thickness is always the same. We can control that. It doesn't cause us any defects. It's kind of the breakdown. You can see the pretty even between resin, solvent, pigment, and then the additives is a very tiny part of the overall. This is by weight, not volume. So how do you know what paint you need, right? Well, it's kind of a balancing act of all of these things. But for most exterior building products, pre-painted building products, you need to lean a little bit to kind of the hard side of that film, but still have some flexibility. If you get too far over to that soft, flexible side, you're going to lose some of your long-term performance characteristics out once it's exposed to weathering. So most of our coil coatings lean a little bit to the right of this chart, but there's a lot of room within the formulations all across this scale here, depending on what you need. Pigments and color, the fun part, right? These are insoluble solid particles that impart color. We disperse them very finely. We want to get the pigments down to their very kind of smallest stable state. As far as size, we disperse it across the resin so you get a nice even appearance. We use two kinds of pigments in this world, organic and inorganic. Your inorganics are usually metal oxides, iron oxides. They tend to be kind of your dull colors, reds, greens, browns, blacks, not very vibrant. Your organic pigments are your bright primary colors, your reds, your blues, your greens, your violets, your yellows, which is mostly what's pictured in the picture here. Organic pigments are beautiful. They have the prettiest look. They're very clean, very distinct, but they don't hold up well to UV like the inorganic pigments do. So we actually don't formulate with organic pigmentation very much, or we do so in very small quantity so that we can get the 40, 50 years without color fade out on a building. The application of color is really important. How we measure it, how the eye sees it, this is something we spend a lot of time on in our world. We do this numerically as much as possible with computers. It's an LAB number, you know, the red-green scale, the yellow-blue scale, the light-dark scale. There's a standard that we read every order to, a master standard color that we're targeting, and we don't want to deviate more than like plus or minus, you know, 0.5 off of that. The human eye doesn't really start to perceive color difference till we get to a 1 unit color change, which is why we operate at that 0.5 level in production so that no one can see it, you know, and it takes a really trained eye over time to even pick up subtle 1 unit differences. Now, we don't use just one paint. We use several different paints to get the final product. So in our core, we have our coated steel. After that, we apply a pre-treatment on both sides. It's going to help create some bite and bonding to the surface of the paint. After that, we apply a primer. The primer does a lot. There's a lot of corrosion protection that comes with that primer. There's also, again, it helps with the adhesion of the top coat. It can help with flexibility of the final product as well. Then we put our top coat on. On the bottom side, the backer side, you also put a layer of paint over that primer. We'll talk about that a little bit more as to why we do that, a couple different reasons. On your top side, the side that's going to be exposed and will show, you may also have a clear coat. And we'll talk more about that in the enhancement section as to when and why you would want a clear coat on your product. It's not needed all the time. It is optional. Okay, common paint systems and their differences. So what I should hold on here before I get into this question. That's the end of our first section. Any questions? It's a lot, I know.
Thank you, Michelle. We have a few questions coming in. First question, how do you control the batch-to-batch color consistency? Is color consistency better with an SMP or PVDF paint system?
A good question. So the incoming paint consistency is controlled by the paint supplier, and they have a lot of process control and QC in place to do that. Control of that doesn't really matter on what chemistry type or paint type, S&P versus PVDF. There is some dependency on pigmentation though. So the metallics and the mica pigments, which are your sparkly pearlescent pigments, are very hard to control from batch to batch. So we consider them batch sensitive. We cannot guarantee an exact color match visually from run to run on those. But all of your other pigmentation, yes, they can control it to the point where it's repeatable on a production line.
Next question. Is there any incompatibility of all zinc paint on steel-based metal material?
So an all zinc paint, potentially yes, but we don't see zinc-based paint anymore. I mean, that's not a, way back in the day, there was some crazy real zinc and real copper pigmentation that was used and formulas that were used that had weird weathering characteristics, but it's just not something we see anymore in the industry. So, all the paints we're going to talk about today and the pigmentation that's used, is completely compatible with the substrate that it's going over. There's no interaction between them.
Okay. Does the backer coat have the same life as the top coat?
Yeah, good question. Normally, no. The backer coat is applied at a lower film thickness and is often a lower grade or quality of paint because it's not going to be exposed. We can coat both sides of the strip with a high-end paint if both sides are going to be exposed. There are options for that to make sure that your paint on both sides is going to perform equally. But traditional backers, no, they're not going to have the same durability and lifespan as the top side, but they're also usually not exposed to anything either. So it's kind of not a concern.
Okay, let's take one more question.
Okay.
What is the difference between baked enamel and polyester, or are they the same?
No, those not an easy answer. Depends on who you ask. I consider them the same. Anything that is a baked on cured paint system is often considered to meet the definition of a baked on enamel paint. If it's, heat cured, chemically reacted, and you end up with an inert, unreactive solid film at the end, it can be considered a baked on enamel. But the definition varies a little bit depending on who you're talking to.
Okay, let's continue on with your presentation and we'll take some more questions in a little bit.
Okay, thanks. Good questions. So next, what are the 3 common paint systems we use for building applications? These are polyester, silicone modified polyester or S&P, and then fluorocarbon or the PVDF, which you just heard about in some of the questions. We will dig into these a bit further, try to understand how they're different and why we have 3 different paint systems. So unfortunately, polyester is pretty straightforward. That's just polyesters. Silicone modified polyesters, you usually refer to as S&Ps. That makes sense. Fluorocarbons gets a little confusing. We as an industry decided to have about 5 different names for this paint system. So fluorocarbon, PVDF, polyvinylidene fluoride. There's a little bit of chemistry for you, is the actual chemical name for it. You may see it out there in the specs as Kynar 500 or Hylar 5000 systems, and that is a licensed technology, trademarked technology for high-end architectural buildings, and that is a very specific resin that has to be used. They're kind of listed here from good to best as far as overall performance and durability. Polyesters, these are like the really workhorses of the coil coating industry at the end of the day. They're very cost effective, really great flexibility, but also great hardness, wide range of color and gloss options. You can get really high gloss if you want that out of these polyesters. Very versatile. You can formulate these in a tremendous range of finished characteristics. So your appliances, your interior stuff, door trims, window trims, T-bar for your ceilings, appliances are all going to be polyester. So they don't need to have outstanding exterior weatherability. But if you use the right pigmentation, really good pigmentation, and with modern polyester chemistry, you can get a pretty good warrantable exterior product out of them. So we do see them for metal, outbuildings, maybe barns, metal roofing. A lot of it's used. All your gutters and downspouts are almost always polyester. Again, light agricultural appliance wrappers. I like to try to equate polyester. So polyester is a type of chemistry. It's a type of molecule. Think about your polyester clothing you wear. That's the same base chemistry as these paints that we're putting on a building that's going to weather for 25, 30 years. So it's a huge class of chemistry, a lot of options available. Lots and lots of different monomers you can react together to get different properties. So a lot of different uses. Silicone modified polyesters is exactly what the name implies. These are polyesters that we've taken and we've added some silicone, reacted it into the backbone of that polymer, if you will. When you do that and you do it in the right ratio, you get kind of a step up in performance and durability in the exterior world. So you get really good weatherability, better in, resistance to shock and fade. Again, you can still get a wide range of colors and gloss. And it's a little bit lower cost than the PVDF or the Kynar we're going to talk about. So this is a really good product. We see this a lot in light commercial and a lot in residential sidewall and roofing applications because it does have really good performance. It's a good cost point. Everyone makes one. Everyone can run it. You can get just about any color that you want. The fluorocarbons. So these are kind of the PVDFs, the Cadillacs of the paint world. They go by several different names. Again, sorry for the confusion. Exceptional shock and fade resistance. Holds up really well in aggressive environments and elements. Great chemical resistance as well. Excellent formability. So this is, you will see these specified for commercial building applications, monumental buildings, government projects, military projects, is all going to be PVDF or Kynar 500 fluorocarbons. To relate this to things that we see every day, the PVDF molecule is only 1-2 atoms different than Teflon. It's in the same family as Teflon. We can all, we all got hands that are made out of Teflon, right? Just last forever. Kind of indestructible at the end of the day. They do not break down. So great coatings, but higher cost, got to have licensed technology to make it. I will talk a little bit about, because it's probably going to come up, there's been some shortages of PVDF in the world the last couple of years. It's better now than it was 2 years ago. They use PVDF, this fluorocarbon technology, this resin backbone, in the lithium ion batteries for electric cars. So there's been huge demand for this product that we've not seen up until the last few years that just continues to rise exponentially. So a lot of work being done by the makers of this product to get more capacity online globally because there's a lot of demand for it in the battery world. And I don't think electric cars are going to go away anytime soon. So just continue to increase. So kind of a quick, cheat sheet here. Polyesters, right? Overall, that's kind of a good to better system. It's cost effective. Warranty is going to be anywhere from none to kind of a moderate, kind of 20-year, 25-year, maybe a little longer, depending on pigmentation. Durability is limited to good. Very versatile, though. Can do a lot with it. Or there's an AMA spec, an old AMA spec that goes with that, which is 2603. Used to be 621, which is obsoleted now. S&Ps in the middle, right? You get a good step up. Really great moderate price point, longevity on warranty, durability is medium to high, wide range of construction, residential and commercial, and of course the PVDFs that we just talked about. I think it's worth mentioning that I would say in the last 15 years, the differences between high-end polyester and SMP has shrunk. That gap has closed tremendously. And the gap between SMP and PVDF has closed as well. And it's really because, the resin chemistry, the polymer chemistry got better for polyesters and SMPs, but it's also around the pigmentation. So if you take a good SMP and you put the top of the line pigments that are getting used in a PVDF in it, you get a much closer performance to the PVDF. So there's some variables there, but yeah, the gaps have shrunk. When I first started, I won't say how many years ago, the gap was pretty big between polyester SMP and SMP and PVDF. Not the case anymore. So what do you need to consider if you're going to spec or you see some paint specs, you're trying to decide what kind of coating you want? Again, we talked about the difference now is becoming marginal. The best is still your PVDF, especially if it's going to be kind of in a harsher environment, an extreme environment. The Kynar 500, the Hylar 5000 name is written into the specs. Kind of hard to get around that. You know, it's in the Corps of Engineering spec as well. And when you are dealing with PVDF, if to call it Kynar or Hylar, just a little tidbit here, it has to be 70% of the overall resin composition of the paint system. You can use it less than that, but you cannot call it by those trade names at the same time. So there's some rules there that the paint suppliers have to adhere to be able to use those names. Okay, so let's stop there and take some questions. It's a lot to cover very quickly.
Okay, first question. Can you discuss FEVE, physical differences to PVDF, cost difference, what's the trends and why?
Okay, that's a loaded question. They're in the same class and chemical family, right? They're both fluorocarbon, but they are different molecules at the end of the day, different polymers at the end of the day, but pretty similar performance. FEVE is a liquid base. PVDF is a solid. You can get higher gloss with FEVE. A lot of the clears are done with FEVE because it's truly, you can get a clearer, crisper look out of it than PVDF when you're formulating with it. It is traditionally been much higher cost than PVDF, which is why we don't see it used very often. There was a move to it a little bit with the PVDF shortage. We've seen some, you know, colors and paint palettes, depending on supplier and users, switch to FEVE because of the PVDF shortage, but it still tends to be higher priced for the most part. It's a little bit lower solids too. Normally we don't get as much coverage out of a drum of paint of it as we do with PVDF. So, you know, on our production side, which doesn't impact anyone downstream, there's some differences. But yeah, it's not used as widely used as PVDF. I can't remember what the rest of the question was. There was like 4 parts to that.
What are the trends?
Yeah, again, trends. Like again, 2 years ago, year and a half ago, when PVDF availability became really critical and really tough, we did see a move to FEVE, but it's kind of died off, to be honest. I'm not seeing much of it anymore. PVDF supply kind of got back to where it has always been, so no changes. I think the cost part of that is probably a bit of a deterrent. It's also not a lot of supply sources for FEVE. It's limited supply chain, which is a concern for some folks about going kind of all in with that technology, right? Kind of putting your eggs all in one basket is a little scary sometimes. So yeah, I think that FEVE talk, oh, is that a viable replacement? Do we need to use it? Just kind of went away when the PVDF supply came back online. But who knows what will happen in the future, right? Never say never.
Okay, next question. How does Gulf Coast salt air impact the paint warranties for each paint finish? At what mileage inland does the salt air have an impact?
I'm going to ask whoever asked that to hold on till we get to the enhancement sections, because we're going to talk about marine coatings in some depth towards the end. But very good question. We will get there, I promise you.
Okay, let's do one more question. Do most metal buildings and roofing manufacturers utilize all 3 paint systems, or do they limit to one or two paint types?
I can't answer for all, but I think the trend has been to have at least 2. Most big panel manufacturers have an SMP or a high-end polyester offer and also a PVDF offer available. depending on kind of what their market focus is. So it's not unusual to find both either 2 or 3 systems being offered by one supplier. That's not uncommon.
Okay, thank you for that, Michelle, and let's continue on.
Okay, so now we're going to talk about the building considerations that can influence the type of pre-painted metal and type of paint you want to use. Right, so here's our question we just had: proximity to salt water. That's a huge one, especially for those of us that you know, whose life is consumed out here on the West Coast or along the Gulf Coast. Desired building energy efficiency, the color you want to use, how visible is the roof, what are the sight lines, what are the elevations, that reflection off of there, what other materials are you going to use in conjunction, and there's some cautions there about mixing materials together. Exposed eaves, unexposed areas, a lot. We're not going to cover them all, but we'll get to the big ones. So there's a wide variety of enhancements available, depending on what you need or want. So micas and metallic pigments, we talked about that. That's an effect, right? So you get that kind of sparkly pearlescent paint. This would also be your color change. Pigmentation falls into this category as well, right? You view it from one angle, it's one color, you move around, it changes color. Clear coats. Clear coats can help with marine locations. Graffiti resistance, that can be built into a clear coat technology. Cool roof pigmentation, so pigments that stay cooler in the sunlight, goes to your energy efficiency. A lot of that's been written into building codes now, especially in California and the Southwest. Texture, we're seeing a move towards textured paints for a couple of reasons. One, the look, but it also kind of kills the glare and the reflection off of painted metal, which can be objectionable depending on where you live and what you're around and the other materials you're using with it. You can also do prints and imagery. It doesn't have to be a single solid color. We can do mixed colors, patterns, and you can actually, we'll see it, you can actually print images on these coatings as well. So the micas and metallics. Historically, we used actual metal flakes to get this look, which is why they're called metallics, but most companies don't use those anymore because they don't weather very well. If you use a true metallic pigmentation, you have to have a clear coat for performance characteristics. So everyone's gone to the micas and the pearlescents, which don't require a clear coat. And yeah, they are batch sensitive. That question came up earlier. These are batch sensitive still. The industry, the paint suppliers all the way through the application side are not to a point where we can reproduce these colors exactly from run to run. It has to do with the orientation of those pigment particles and how they lay out on the strip, and the fact that we are coating in a directional manner. So there's directionality to them, which is a caution here. This is why you don't mix. So a couple of examples here, but batch to batch differences, but because the directional, how they get installed, they might look different. So these two issues here are actually direction. These panels all came out of the same coil painted at the same time, but some panels got switched in their direction. So now they visually look like a different color because of the way those pigments reflect light. Not as obvious on the right here, but you can see that there's some subtle shade differences from panel to panel, and that's an orientation issue. So the coil coaters can often help or overcome with this by, on the back side, branding with directional arrows, so you know what direction they should all be facing or going when you make panels. Okay, extreme environmental enhancements. This is probably the biggest one I deal with in my world, and that most panel manufacturers deal with, especially along our coastal regions. So yes, you can get pre-painted metal systems modified for specific environments, including coastal. You're usually going to have to go with a higher build primer, so a special primer for marine locations. It's at a higher film. You may also have to put a clear coat over the color coat to get warranty. These are 3 to 4 coat systems. You may have to increase the film on the backside as well. You should be able to get a warranty though. The definition of marine, definition of saltwater does vary by paint supplier a little bit, which is why my recommendation is if you're within a mile of breaking surf or saltwater, You need to have the conversation early on with whoever your supply chain is going to be about what they consider a marine environment. I see it everywhere. It is as close as 1,000 feet. As long as you're 1,000 feet or more, you're good to go. You don't need a marine paint system. Some of my supply chain defines it as 1 mile. So it's not consistent. So yeah, just because you see it in one place, say it's a half mile, doesn't mean that the next supplier, coil coater or paint supplier, has the same definition. Clear coats, right? So clear coats can add kind of depth or a certain look to your product, but it can also bring performance, not only with helping with corrosion performance, but graffiti resistance, right? So there's special clear coats out there that really kind of nothing sticks to them, right? They're really impervious. They're very slick. It's hard to get any kind of graffiti or coating to stick to them. But if something does get on them, they are also very easy to clean off and wipe clean quite well. We also can use clear coats to get added hardness or mar resistance to protect around food staining. So in food display applications, there's often a clear coat used, and then the graffiti. I will say that when we say a clear coat in our world, they're not 100% completely clear and translucent. They have a slight yellow undertone to them. That is because of the, quote, transparent kind of sunscreen UV blocking particles that are in there. So on lighter colors, in this photo here on the left is just a normal paint system, a white and a red, no clear coat. The middle samples have high build primer underneath them, so for a marine environment, and then the samples on the right have a clear coat added. You can see that on the light color, there's a slight visual shift in the color as you apply that clear coat, but in your medium and darker tones, you won't notice it. And this is just kind of a heads up. There's no way around that. If we went with a completely translucent, completely clear coat, you wouldn't get the enhanced performance that you need out of it. So it does shift the visual color a little bit. If it's objectionable on a lighter color, the paint companies can reformulate the color coat that's there to offset that yellowness. So you can have that conversation, but it's usually a very minor difference. Unless you point it out to someone, they usually don't notice it. Backers, we had questions around backers earlier, so we do have a section on backers. It's often an overlooked item and underappreciated. Backers don't get a lot of love, usually because they're not seen. It's usually some kind of off-white or light gray color. It is color, we applied it a consistent film and color, so it always looks the same. Because there are applications like open frame metal buildings where you do see that backside. So you want it to look good, you want it to look consistent. But we apply it for a couple of reasons. One, if you left it bare, when you wrap that unpainted side up in the coil against the painted side on the top, it can damage the painted side. So we apply it so there's some protection while it's being shipped and handled. It also does help with corrosion performance as well. And then, of course, there's times where you're going to see it. And as I said, almost all coaters can double paint, right? So we can paint both sides of the strip the same color, 2 different colors. We can do full films. I mean, we can do a PVDF full coat, color coat on both sides of the strip if that's desired. It does happen from time to time. It's a lot of like screen walls and other applications where you're going to see that backside. And you want it to be a certain color. Cool colors, right? So this comes from the pigmentation. So cool pigmentation are pigments that have been altered to reflect more IR radiation without changing their visual color. So you can get a dark brown or black. The darker color is still dark in visual color space, but are reflecting high IR, so they stay cooler. Any paint system can be modified. If you use these pigments into any type of paint, you're going to get a cool effect. It has become pretty standard in our industry. You typically don't have to ask for it, especially in the PVDF coatings anymore. Almost everyone's formulating with cool pigmentation as a standard these days. But when in doubt, ask, and they should be able to tell you specifically what the solar reflectance is, what the emissivity is, values are for those paints. Some more. We do have some terms here that get a little confusing. We have solar reflectance. That's the amount of solar radiation being reflected off the surface. That is different than light reflectance. It is different than gloss. We have emissivity. That's the amount of heat a surface dissipates away from itself. We then have the solar reflective index, the SRI value. This is what you will see in the LEED specs. This is what you'll see referenced with the Cool Roof Rating Council, Title 24 here in California and other building codes. This is a calculation using the solar reflectance value and the emissivity value together. It's a very long, nasty equation to get an SRI number. Cool Roof Rating Council, you know, the Energy Star roofing program has been sunsetted now. That's gone. The Cool Roof Rating Council is our third-party independent entity that kind of monitors everyone, keeps us all honest on these values. It does the testing. So I will give a shout out here to pre-painted metal. Unlike other building products that have kind of a quick deterioration and loss of color over time, that also impacts your solar reflectance. But because these paint systems last so long and maintain their initial color for so long, our aged SRI values, there's typically no change in the first few years, even long-term, no change. So they stay cool for a very long period because they're such good stable paint systems. You will find these, most panel manufacturers do include this info on their color charts. If you're looking at one of their color palettes, they'll have SRI or SR numbers. The LRV numbers that are here, that is the light reflectance value, right? So that's kind of dark light space, nothing to do with cool performance. Again, there's probably a lot of people on this call that know way more familiar with LEED than I am. I know enough to be dangerous, but yeah, right. So low slope, steep slope defined. Initial SRI is 82 for the low slope, 39 for steep slope, age 64 and 32. The lighter the colors, the higher SRI. You can get to 39 now with cool pigmentation, kind of in the medium range colors as well. That is achievable. Gloss and sheen. This is something else that's become a hot topic of late. So gloss and sheen are two terms we use to define the visible shine off of a surface and the angle of viewing in which we see it. So 60 degrees is gloss, 85 degrees off the surface is sheen. High gloss, high sheen is a high glare surface, while low gloss, low sheen surfaces have kind of that matte or flat finish. Again, different than LRV, different than SR values. Be a bit confusing. We're seeing over the years a trend to move to lower gloss and lower sheens. Like that's kind of been happening for the last 20, 25 years. Now we're seeing a demand for really, really like no gloss, no sheen value paint, super matte finishes, especially in residential. One, because of how it looks, it blends better with other materials, but also, you know, I love my product, but I don't want to wake up to a neighbor's metal roof who is blinding me through my windows as the sun comes up in the morning. So there are areas that have built into their building codes some specs around not having high gloss, high sheen because the neighborhoods don't like it, citizens don't like it. It's been in place for a long time around military bases and airports because you don't want pilots getting blinded by roofs as they're landing or taking off. It's no good for anybody. So yeah, we just talked about this. How do you do that? How do you lower this gloss and sheen, right? Well, there's a couple techniques. So you can use flattening agents. These are additives. You can texturize the surface. So then that bounces that light reflectance around. You don't get as much coming back at you. This can be done chemically or with actual particles in the paint. The samples here, the panels in the top picture, those are numerically via the color computer, the exact same color gray. But you can see how different they look to the human eye because of the low gloss, low sheen on the left, standard gloss and sheen on the right. And again, we have an example here on a black. These are actually the same blacks. They just look different because of the gloss and sheen. LRV is the same. Huge gloss difference, huge sheen difference. SRV and SRI, cool properties, almost exactly the same though, even though we've killed that gloss. So not dependent on each other. Here's our fun stuff, the prints and the patterns. I really like these. I wish more people would use them. It doesn't have to be a solid color, right? It can be a combination of different colors. Now we have to put the strip back through the line a couple times to achieve this and have special rolls that are etched or laser engraved to get this pattern, but very doable. All the same paint system. So you put a base of, say, your PVDF down of a solid color. You'd come back over it with a contrasting print color to get these kind of patina looks. You can do wood grain, brushed looks. Pretty short development time to come up with these. We are limited by our roll size, so there is a little bit of a repeat of the pattern. It's one limitation. See this a lot for exterior roof and wall designs, especially wall designs of late. A lot of prints being used. There is printing capability in laminates. So laminates are printed decorative sheets, imagery on a film. That film is then bonded to the steel strip. Mostly more for interior and like for doors, garage doors, that kind of thing. Don't see this too much on the exterior of buildings. Doesn't have as good a durability and UV resistance as standard paint systems. That bond of the film to the substrate can break down. But digital printing, a lot of headway made in digital printing in the last few years, using paint systems very similar to our standard PVDFs and SMPs that we're using now. They use it as an ink. It's kind of like a giant printer that sits on your production line and prints an image as the strip is moving. It can be done large scale. So kind of fun. Okay, any questions there? We're getting tight on time. Any questions around the enhancements? I hope I answered the marine system question.
Yeah, we have a couple questions here, Michelle. Two questions. I'm going to group them together though. Does lower gloss and lower sheen reduce durability? And it seems that a low gloss, low sheen option would reduce the visual effect of oil canning. Okay,
great question. So no, the durability is not impacted. It doesn't have any part of that. So same warranties, same performance expectations. Now, I will say, right, chalk and fade may be less noticeable because you're starting at a lower gloss. You know, your gloss retention is difference over time is going to not be as noticeable because you're starting at a low gloss to begin with, right? So you don't have any gloss to lose to change that appearance over time. And then the second part was, and the other question I get, I'll throw it in there, is around, you know, these textured surfaces, these rough surfaces, do they collect dirt? We've not found that. We've done the testing out in the desert, and they don't collect dirt or dust any worse or more than a regular painted system. Something that comes up. What was the second part? It was around oil canning, right?
Yeah.
Yes, it does. A matte finish, a low gloss, low sheen finish can hide a multitude of sins, including oil canning. It does minimize that look. It's still there. You just don't see it as readily. Yep, absolutely.
Okay, let's continue on, Michelle, with the rest of your presentation.
Okay, so this last part is going to be around the warranties and performance. So, you know, what is warranted on these systems? Typically, you're going to get some kind of warranty. If you're using a Galvalume or a Zincalume substrate, you're going to get some kind of corrosion warranty around the substrate. On the paint side, you're going to get film integrity and then chalk and fade. And we'll talk about what those mean. So the warranties are anywhere from, you know, 5 years up to 40. I think we're seeing some 50-year warranties now on the paint films. It's usually for excessive chalking, excessive color fade, and then delamination of the top coat of the primer to the substrate. That's your film integrity. Basically, is the paint going to stick long term? Failures around these can be due to a lot of different reasons. Improper application, issues during installation. It could be a bad paint formula. Maybe the coater didn't have good quality control. There could be environmental conditions that play a part and impact how well it performs. There are significant differences between the paint system types and the warranty coverages. I've got an example here. This is old, and again, keep in mind that the gap between polyester, SMP, and Kynaris has changed, but back in the 80s into the 90s. So they installed this wall, all using the same visual color to start with in these different paint systems. Checked it, 14 years later, and you can see the significant difference in fade of the acrylic and the polyester versus the Kynar and the S&P. So, yeah, they do perform slightly different. They're not quite this bad now, but you would see, if you were to mix an S&P panel with a PVDF panel out in the field, same initial color, same pigmentation, 20, 30 years down the line, they're not going to look exactly the same. Now, they might still be in warranty and doing well, but they're not going to look the same. So chalking is exactly what it sounds like. You actually get a white chalky powder on the surface of the panels. This is degradation of the resin or the polymer system, kind of getting broken down into smaller bits and pieces, and then now it can come off the surface. It's got some pigment embedded with that, so it gets this white faded appearance. You can wipe your hand on there, your hand will be chalky. This is done by UV rays. Do not see this very often, I have to say. Kind of rare anymore. Most of even the high-end polyesters, you're not going to see this kind of degradation like you used to. So again, warranties 20 years and plus against chalking. There is an ASTM method for measuring this. The higher the number, the better the performance. So a 10 means that there's no chalking at all, and 8 would mean very, very little chalking. And you use either a black or a white like velvet material, and you wipe it on the surface, and there's a visual reference that you compare it to come up with your chalk rating. So a little bit subjective, but again, don't see it very often anymore. Color fade. This is the one most people are worried about, right? We want our building to look the same. We don't want to have noticeable fade, and we really don't want it to fade differentially from one part of the building to the other, right? We want it to fade evenly. We know it's going to fade, but we want it to look consistent. So again, this is UV attack on the pigmentation. We measure it by a number called delta E, which is a numerical color calculation. Most paint systems are warranted for they'll say things like allows for a delta E change of 5 units over 20 years. Okay, so that means in 20 years it can change up to 5 units and still be under warranty. Human eye doesn't start to see that change until you're between 0.5 and 1 unit delta E. So it takes a little while for the eye to see it. Your PVDF systems typically have the smallest color change over time of any of them. I put some examples here of what this kind of visually looks like. So this is at the top is what the color started as, and then we have a 5-unit change in the middle, and then a 7-unit color change at the bottom. Same with the red. Again, we all know reds, dark blues tend to fade a little bit more. Blacks are going to fade a little bit more than lighter colors, or it'll be more obvious. The picture I have here at this house, we call these candy cane. I call them candy cane or candy roast, where they're striped like this. There's a couple things that could be going on here. When you have some panels that are performing or fading differently than others, it could be a few things. It could be mixing paint systems. Someone could have intermixed, say, PVDF with a polyester or an S&P with a polyester. It could be that part of these panels were not at the right film thickness when they were made, so they're fading faster. It could be different paint suppliers, right? So, blue number 14 from supplier A and supplier B may not be formulated exactly the same, and they may not fade exactly the same. So you don't want to mix suppliers on a building either, because you will get differential performance. Paint delamination. This is a really tough one. So this is loss of paint, either the top coat to the primer or the whole system down to the substrate. Can present as bubbling, peeling, different ways, cracking. There's actually about, I think I'm up to probably 75 different root causes for this, but I've listed the most common ones here. Low film, that's on the coater. Incorrect pre-treatment. If your pre-treatment and your cleaning wasn't good of that substrate, you may not have gotten good paint adhesion to the surface. If your curing of the paint wasn't good, this can happen. Incompatibility between the top coat and primer. Maybe you used the wrong primer with your top coat that day. And then mechanical damage. This is installation damage. So this is mechanical damage in the picture. I don't know if you can see that everywhere where this paint is peeling, there's a very distinct vertical line that it's peeling off of. These were scratches that were caused during installation. You now have an opening in that coating where water and moisture and other stuff can get in there, UV, and that paint starts to peel away from that scratch. You know, it'd be like if you went out and scratched your car. It's not going to hold up at that scratch long term like it does everywhere else. Other failures we need to talk about. I know we're at 12:15, but bear with me if you can. We do see issues because of incompatible dissimilar metals. So in a corrosive environment, there's certain metals you don't want to mix together in direct contact because it'll cause premature corrosion of one or the other. Using wrong sealants, leaving swarf, which is metal filings from the drilling process or cutting on site that takes place in these panels. That rust leaves a stain on the surface. Wet stack, this is storage corrosion. So the panels, when they're stored prior to installation, if moisture gets in between those panels and they're not allowed to dry out, you will get premature corrosion starting underneath the paint system. Paint system then comes off once it's installed. Looks like a failure. Oil canning, not a failure, but it does happen on light gauge rolled steel products, which is kind of that buckling or wave that you might see in certain panel designs after installation. Dissimilar metals, a little bit in depth here. So basic galvanic chart. So more active on the top, less active on the bottom. The further away they are, the more of a problem you're going to have. And this is in corrosive environments, especially marine environments. If they're in direct contact with each other, the more active metal is going to sacrifice itself and corrode prematurely. So this is a stainless steel lighting fixture canister recessed through a galvalume painted panel that is 300 feet off the surf break in San Diego. So high salt content, highly corrosive. This kind of lighter area, this rim that you see around there, that is the paint bubbling off because the substrate underneath is being destroyed and it has nothing left to stick to. Dissimilar metal corrosion. Not good. We have whole books of technical bulletins and papers on this topic if anyone wants to know more. Concrete, wet concrete up against these painted panels. You got to have a water barrier or you get moisture into that steel substrate, causes corrosion. Treated wood is a big one. So treated wood, either wet wood that's still damp or wood that's been treated with fire retardants that contain copper, are problematic with painted metal. You will get corrosion. So this deck right here had treated wood. The water was running directly off of it onto the metal panels below, causing areas of corrosion. As soon as you got out past the deck where you didn't have that water runoff, the panels were fine. Swarf and metal filings, again, these are little shavings of metal from like a screw hole or cutting that don't get cleaned off. Those little metal shavings are now rusting because they're exposed to the environment. This comes into me as, hey, my paint is failing and it just got installed. And then I look at the pictures and I go, nope, those were metal filings that didn't get cleaned off. This staining that happens on the paint surface is really hard to remove. Not a performance issue long time, but definitely an aesthetic issue that most new building owners are not happy with. So we have a lot of tech bulletins around how to cut, how to clean, the best way to prevent this and to get rid of it if it does occur. This is the wet stack I was talking about, or corrosion, storage corrosion that occurs. Can happen during transport, during storage. You can get moisture due to sweating. You can get moisture due to actually rain or precipitation in between the stacks of panels. There's no good airflow. It's a chemical reaction that takes place underneath the paint, starts to push that paint off. You get these little tiny, like micro blisters almost. It kind of feels rough. And then we talked about lumber. Don't let that be in contact while it's being stored. I keep it off the ground, covered indoors if possible. Some paint systems and metals are more resistant to this than to others, but there is no guarantee for any of them that this won't happen. This condition, if the temperatures and humidity levels are just right, can present in a matter of days or a week at most on a job site. So it can happen very, very quickly. Here's our oil canning. Again, not a paint failure, not a paint issue, but it always comes up. Kind of this buckle or wave appearance, especially in standing seam, big span standing seam. Low gloss paints help with this. You're not going to see it as much. Adding striations or some forming in between the seams helps as well, breaks that up, gives that metal somewhere to go so you don't have these pockets that are loose. You are going to always want to specify tension leveled material. Again, stiffener beads or striations. an embossed surface, right? Put a pattern embossed on that steel will also break this up and prevent it. And then lower gloss coatings are a good option. Okay, so how are we going to avoid any of these failures? We're going to use the right paint spec, right? We're going to get the right paint for what we're doing. We're going to understand our environmental conditions that we're building in. Use a good coil coater, knows what they're doing. Don't mix batches of metallics and micas. Use a reputable panel manufacturer. It's got good packaging, can talk to you about paint surface protections, has good instructions on how to install. A good installer. Not all roofers know how to lay down metal. This is a problem, especially in residential. Make sure they know how to handle it, how to get it in place without damaging it. And then cleaning. All the warranties will have maintenance and cleaning requirements in them. It's like your car, right? You're not going to drive your car for 3 or 4 years and never wash it and then complain about how it looks, right? And it's great. Metal's easy. You just hose it off. You just wash it off. It's easy to clean. Not a problem. The constructs of a coating warranty, just kind of some heads up stuff. They're all a little different. Understand the details. Do not get caught up in the headlines. The title might say lifetime or 30 years, 40 years. You got to read further in. What is warranted for the lifetime? Is it prorated? What is warranted for 30 years? How much fade is going to be allowed? How much chalking is going to be allowed? What's the warranty for film integrity might be different than the duration for chalk and fade. So you've got to kind of read in past that title into the first few paragraphs at least, please. There should be a definition of marine in the environment somewhere. It'll have a list of exceptions and considerations as well that you need to be familiar with. So it's a little boring, a lot of legalese, but they're usually one-pagers, so not too bad. Again, more of what I just talked about. We're past our time, so I'll let you guys read that. We're at the end. It's long. I know it's a lot of information. Any questions before we finish up here?
We've got one last question, Michelle, that came in. What should we do if wet stack material shows up on the construction site?
Do not install it. You need to contact the panel supplier and take good pictures, document it, and talk to your panel supplier. If you install it with that condition, the paint will eventually fail. And what's interesting about it is it may be several years before that paint actually starts coming loose. So it's kind of a delayed. It can be a delayed failure. Which is then hard because to say to a homeowner, well, it had this condition when it was installed, they go, well, but it's been 5 years and it's been fine. So how could that have happened 5 years ago? So it's a complex conversation. But if you see it at a job site, hold up, don't put it on the building. Call your supplier.
Okay, thank you, Michelle, and thanks to everyone who joined us today. That's all the time we have. Just a reminder, if you need to reach out with any additional questions, the presenter's contact information is currently up on the screen, or should be, there it is. Before everyone leaves, if you would like to rewatch today's presentation or share it with a colleague, we'll be emailing the link to the recording to everyone who registered for the webinar within a week. As well, it may take up to 5 business days if you're requiring a certificate, so keep an eye out on your inbox and don't forget to check your spam or your junk folders. Finally, after you shut down Zoom, you'll be taken to a survey to provide feedback on your experience today. Please take a moment to complete the survey as it helps us to continue to serve your needs in the future. Thanks again, everyone, and have a great day.
Thank you.